Okay, hi everyone. My name is Alice Di Bella. I'm a PhD candidate at Politecnico di Milano at the second year. I'm also working with the European Institute on Economics and Environment. And today I would like to present you the results of this research about the impacts of European policy on the power sector in Europe using the PyPSA-Pol model, which is a new version that I'm currently developing of the PyPSA-UR model. So, some of you might know the PyPSA-UR model. It is an open source energy system model using open data and built on the European energy sector. So on top of that, we developed a framework that can apply the different European policy in order to do policy evaluation and see how the different energy sectors react to the different type of policies. So we have the European climate law that states that we need to go net zero by 2050. The Fit for 55 package that has many policy provisions requiring to arrive at 55% greenhouse gas emission reduction by 2030. So we try to implement many policy provisions in the model and see how the energy system reacts to that. So you can also see the different energy sector and how they are divided into the various emission trading schemes and how the different targets are then set for the different years in the transition scenario. So the results are then aggregated, and we focus now on the power sector, and we aggregate the data and the result for different European regions in order to have a more specific policy message for the different regions, since in Europe we have many different characteristics based on different countries and areas. So we divide it into Southern Europe, Northwestern Europe, and Eastern Europe. And then we develop two scenarios in order to compare them. A reference case that is without any type of policy, and then a policy scenario, Fit for 55 plus, applying all the policies that we mentioned before. So in this slide, in this case, I show you the CO2 emissions in the different cases, in the two different cases for the various areas in Europe for different years. And as you can see, there's a large room for CO2 emission reduction for Northwestern Europe, while for Southern Europe, we can see that the model also goes to negative emission in some cases. Why that? In south of Europe, we have a large availability of the sun resource, and we can build a lot of PV panels that are going to produce a lot of cheap electricity that can be used for direct air capture in this case. Then I also wanted to show you what happens to the share of electricity production, so the different, in the two scenarios, so in the top row you have the reference scenario, and then you have the policy scenario in the bottom row, and then for the different European regions, what happens to the electricity generation mix. So you can see that in Eastern Europe, coal is very difficult to eradicate. It's a very diffuse technology, so you need a lot of investments in order to change the electricity mix. And then also a lot of investments are needed in Northwestern Europe in this case, but mostly because wind is a largely available resource in this area, but it's still a costly technology. So we will need a lot of investment to build a lot of offshore and onshore wind sites. While for Southern Europe, even in the reference case, we have a lot of electricity generation through solar, which happens also in the reference case. And so to go further to achieve the policy target, we don't need a huge investment, a huge change in the power system mix. So these are briefly the results for the power sector, but I'm also working, and I wanted to share that with you, about integrating socioeconomic aspects into energy system modeling, and I would like to do that by model coupling, so using a general equilibrium model coupled to the PyPSA-Pol model. Then I would like to develop further the industry and how it is modeled inside the PyPSA-Pol, and finally to include and integrate climate impacts on energy demand and supply. So thank you, and I'm happy to discuss at coffee break or lunch.